No tere hommikust siis. Pooled on juba kohal. Osad viibivad. Lubasid tulla natukene hiljem. Aga selles mõttes, et ega me neid ootama ei hakka. Tulevad. Timod on valmis. Timod sisustavad siis meil hommikuse poole aja ära. Pärast lõunat läheme siis merele. Karikad on seal näha, seal kohvikarnade juures. Tänase tuulega läheme välja, meil on 6 tevat. Roolis on purjespordikooli õpilased. Nad on kõik võistlejad. Et selles mõttes on see, et see aasta ei ole selline rahulik võistlus. See aasta saate nagu korralikult sillida. Aga enne seda, kui te vee peale saate ja süüa saate lõunat, tuleb meil ära kuulata mõlema Timo jutt. Timo hakkab siis nüüd pihta rääkima, et kuidas nagu Extreme näeb siis tänu sellele, et meil on nii Brocade kui Avaya on siin tootevalikus juures, et mis on see hea ja tubli asi, milleks meil Brocade ja Avayasid vaja on. Aga Timo, floor is yours.
Okay, thank you.
So,
let's start. So, good morning everybody. And so my presentation is more focusing to the legacy Brocade stuff and it's still relatively new to us as well. But I try to describe then what are the benefits and what kind of different kind of fabrics we have, what is the idea of the fabric, how we think that data center should be, let's say, designed and so on. And of course, all the slide set has to be some high-level introduction as well. But there is just about data centers, flagship or alternative solutions. So it depends completely about the need of the data center, scalability and so on. Then the fabrics, use cases, designs, and some routing. And then I also added a couple of things about what we could do with the legacy purple devices. So about the Summit line and how to do either data center or just regular network from that perspective. Then I think the other demo is focusing more to the access level and wireless and so on. And if you have any questions, just let me know. Let's try to keep it as informal as possible and so on. So, and hopefully afternoon we will get just sailing or let's see. I haven't done that before, so let's see that is it this year or not, but let's see. So, yes, everybody knows that it will be everything what can be digitalized will be for sure. And what kind of extra requirements it is setting up to the network. It's more data, more users, more everything, and so on. And if we are thinking about the IoT as well, so if the 95% of the IoT devices will be yet 2020 connected to the network, so somehow we should have a visibility as well, that what devices we have in the network, what kind of traffic or applications is running through the network, and what are the user experiences. Hopefully you have seen this slide at least a couple of times before. It's just about everything should be kind of business or related, but it's just about how the IT can make their users happy or more happy. It's about IT initiatives like bring your devices or moving to the cloud or coming back from the cloud to on-prem because it wasn't good, or it can be big data or analyze or whatever. And if we are thinking about the business side, it's just customers buy more or make employees more happier or satisfying regulations and so on. So how IT can be middle, it's just basically building more agile networks and really be flexible enough to fulfill those business needs. So there's no any shadow IT, or that we really can be flexible enough to just fulfill all of those needs what our customers are expecting from us. So we are talking about the customer-driven experience, and here I don't know how well, but it's about this digital transformation, and my part is here. Timo is talking about the Smart OmniEdge, and then automated campus is like you mean about that's like a core networking. So it's data center access and core. Of course, there has to be applications. Most likely all of the vendors are going more and more to the application direction. Nobody is really claiming that we are very proud and we are making hardware. Everybody is saying that we are application driven and application is the key. Which is pretty much the truth, because it's just commercial silicon, it's just chipsets. Really see and configure what is happening in a network. Also, we are supporting, or we have put quite a lot of effort that we can support third-party devices and so on. So it gives you a better visibility, for example, from HP switches or Cisco switches, so what you can do and so on. Also, it basically the management gives you ability to, for example, integrate or give the same security rules in Amazon Cloud what you have in your own data center. There's one slide later on about that. But so it's just about, if you think about the management center overall, there is basically 4 or 5 different, let's say, building blocks. The management center is kind of like an umbrella. Then there is extreme control, which is basically network access control, and so we can see or we can answer that what devices you have in your network, and you can also control that where those devices have access. If we are thinking about the IoT, it's more and more important that we really have a visibility about what devices we have in the network, and we have also capabilities to limit where those devices have access. And it works with the wired and wireless, so no any differences. Then hopefully everybody remember, I don't know, was it my presentation or the other Timo presentation about the analytics. So we really can measure the user experience and get insight information about how the applications works. And I think the most important thing is just really differentiate what is the network response times and what is the application response time. So we can see that if something fails, is it because of the network or is it because of the server and applications? So we don't have to guess anymore, so we know it for sure. It's based on users, locations, devices. Then just regular management and information governance engine. So basically this is building block where you can check that how well the security features are applied into your network. And then last but not least is basically Extreme Connect. So it really gives you possibility to make an integration to firewalls or something else. So it's just like a API where you can or you can have a connection to external world from the network perspective. And then if we are looking about where we are investing at the moment, what we are doing is it has been pretty much about now getting all the pieces together into the management and like workflow automation. I have a slide about the workflow automation and what it means, but it's just more and more overall concept about the automation. So it's not just about the network, but it's just the process automation. And then in this quarter, it's just about the mobility and how we can connect cloud things and on-premise things together. Then I would say that next half year is pretty much about this. So predictive analyze, and so we really can analyze the base flow or base data in a network, and based on that, if we can see that there is some threats or something, we can start to act. And it related with the machine learning and artificial intelligence as well. That part starts from the wireless, but it will go through the whole wireless and wired network in the future. So I think in the long term, it's just about everything should be automated and everybody should be happy and everything should work. But let's see what is the reality and so on. So at least personally, I'm a bit skeptic, but let's see. And then this is so far away already. So if we are saying that we are doing something after 1 year, normally it's either completely bullshit or we don't know really that what is happening, but we have to have something. So multi-tenant and scalable distributed environment. So again, these slides are made for the US people. So you can just think that what is realistic and what is not, but from my perspective, everything until this is more or less set to the stone, but this is too far away to be really real truth or something like that. Any questions, comments so far? So basically, if we are looking about this slide, and here we can see pretty much on a high level at least what devices or what building blocks we have. And have to be honest, but normally at least extreme presentations are so much solution oriented these days. So no any real engineering, so how many ports or what are the capabilities and speeds and fees. But here we can see quite well that what is our core data center products. And here you can see also different fabrics. And I will touch much more detail about VCS fabric and IP fabric and what are the differences and so on. Timo, do you have anything about regular our campus fabric or anything in it? No. So basically this is more like building large campus networks. It can be countrywide network, it can be just one single city network, or it can be just one single, let's say, building network. So it's really scalable things. But here we have those SLXs and VDXs. MLX series is more about routers and so on. Then those VSP series is basically legacy Avaya things. Then our 8K Black Diamonds, PDX8, S series, K series, and so on. Then these ERSs are small routers as well. And then about, if we are starting from this fabric, it's about this path bridging, SBBM basically. So it's actually building a fabric with those devices. It's very easy. It can scale up to 16 million different, let's say, virtual network in a network and so on. It's coming from Nortel or in the first place. Extreme had it as well when we had Black Diamond 20K series, let's say 5 years ago. We wasn't that successful because there was just about how to do layer 2 signaling. We were relying on our EAPS protocol, and here it's about IS routing. Everything is happening in a layer 2 level. So you don't have to put any IP addresses, and you can still get nice, scalable, easy configurable network. Then if we are looking about those softwares and services, so Workflow Composer is just, you can automate processes. Then, okay, Management Center we already discussed. Extreme Cloud, yeah. At least in Finland we haven't been so successful to sell Extreme Cloud, but it basically means cloud management for the access points and switches. And we will see a lot of effort for the cloud next, let's say, 6 months, and let's see how it goes.
Sorry.
Yes?
You have the Workflow Composer separate from the Extreme Management Center. Are those separate services, or
this is coming from the Brocade side, and basically we are currently integrating that this Workflow Composer into the Management Center. So Timo can explain a bit more about more detail, but it will be here okay, it's already, but
it's beta feature currently on the X-ray management. So basically you can do modeling of those workflows on the management center and basically create some scripts, and you can have different triggers on the workflow. So basically if you get some input from, let's say, some log entry or SNFP trap, or I don't know, there is multiple ways of getting the input signal to those workflow models basically, and you can just draw it like how it works in real life and map some actions to those. And it's currently available as a beta and should be, let's say, GA on the next release. And of course, yeah, you can utilize the Workflow Composer as a standalone product as well if that's what you prefer, basically. Yeah.
But was the Workflow Composer for free or no? There was some fee for that.
Yeah.
Okay. Yes. Anything else? Everybody's still awake? Good. So let's have a look about those data center things. So there's a data centers and there's a data center. So it can be small data center somewhere in cabin, or it can be real data center somewhere. So let's have a look about the building blocks and how to start build real data center, not like the left hand side picture. So, as I said, this presentation is focusing more on those legacy brocade stuff. So it's about the SLX switches and VDX switches, and a few slides about the routing as well. So, of course, we have to have some kind of internet connectivity. Normal internet exchange is layer 2. At least in Finland, all of those 3 places, it's pure layer 2. As fast as you can deliver packets, that's the most important thing. Then you have to have, of course, the routing, so you have some kind of connectivity to outworld. And then just if we are thinking about the topology of the data center, so it's something co-aggregation or spine and leaf topology more and more these days. You might have 2 or 3 different data centers, and you have to have some kind of interconnection capabilities. How you do it? Is it layer 2 between the data centers? Most likely not. Then, if you still want to have a same IP addresses on the same both sides, is it VXLAN tunneling or what you will do, and so on. And then just about the fabric, so is it layer 2 fabric or layer 3 fabric, and what are the advantages and what are the, let's say, disadvantages on the both, and so on. So then if we are looking about the applications, so Extreme Management is just regular management, and then the Workflow Composer, and then basically the automation. It's just about how easily we can really build the fabric and get our data center up and running. What it requires, how many commands we have to type, and so on. So if we are thinking about the very classical architecture, so it's core aggregation access. I think first time when I saw these kind of pictures, it was 1990 something. And in those days, of course, the spanning tree was the only thing how you can build redundancy, and then we got the rapid spanning tree and blah, 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 but it was always north-south optimized. So we had access devices here and everything, all the traffic went to the core and then it came back and so on. All switches individually managed, no any virtualization, very basic stuff. But the way of the design has been always like this. Okay, if you have a smaller network, then you didn't have a real core, but then it was just basically, okay, core and access or something like that. And then if we are looking about the regular fabric, so it's more like a topology freedom. So it can be full mesh, or it can be partial mesh, or it can be just hub and spoke or whatever. It's more optimized to the east-west traffic. And I think it's really important in a data center. So when we are going more and more, let's say, hyper-convergent way, so perhaps we don't have the storage anymore, or we don't have SAN network. So it's more and more those servers are discussing between each other. So then the east-west optimized is really, really, really important. Okay, all links are active, so there's no any real blocking mechanism or need for blocking anything layer 2 traffic. And fabric management is this Ethernet fabric looks just one single switch, one single management IP address. Okay, it's a virtual machine aware, and it's easy to virtualize over. And before these merges with the Amaya and Brocade, basically Extreme didn't have any fabrics. And now we have 3 of those. And here we can see that what are the biggest, let's say, differences or how it goes. So if we are starting from this campus, and it's about SBPM, so it's about bridging and so on. So it's again completely topology agnostic. It forms the flow tree by ISIS routing, so it's very scalable, very robust, and so on. And then it's about the Mac and Mac encapsulation, how we are making either layer 2 connectivity or layer 3 connectivity inside of the fabric. It's also VMware it had VMware integration, and it's pretty much automated. So you can add links, you can remove links, you can add switches, you can remove switches. Everything is more or less done automatically. And when you are provisioning new services, you are provisioning only those into the access level, and all the core is automated or propagated automatically.
The host has left the conference. The conference is about to end.
Routing protocol is just advertising that we have the service here, and if we are adding it here and so on. So you don't have to do any manual configuration in a core. Then if we are going to the left side, VDX series and VCS fabric, so it's more, so this can be in a data center, this can be in a campus, this can be wherever. VDXs are more like data center stuff. And that, again, it's completely topology agnostic, so it can be again full mesh, partial mesh, whatever. And this is basically based on Green. So that is handling everything inside of the fabric. Again, virtualization, and it's completely automated. So you can start to just adding more links between the switches, and automatically it adds those into the fabric, and it's just increase bandwidth and so on. Everything happens automatically. So it's very easy, but there's limitations. And let's go a bit more later with these. So this VCS fabric works only with the VDX series switches. And then there's IP fabric, and that's based on BGP protocol. So it's about much more scalable comparing to this VCS fabric. But also, then you have to make sure that you have layer 3 connectivity in the first place. So there's some commands or something what you have to do up front that you will get it up and running. So it's not that easy comparing to this one, or even comparing to the right-hand side the fabric. But we will have much more detailed slides about what are the real differences and so on. But this is just high level that now we have 3 fabrics and I'm just giving it to all of the neighbors. And then of course later on we can just replace everything, but just in a way that you don't have to take everything down immediately and change everything in a day one. But you can really start to building fabric with 2 or 3 switches, and then in a long term you can just get it fully migrated. First, real product slide. So, if we have, I suppose that everybody is familiar with the spine and leaf thing. So, spine is like core devices, and leaf is just where you are connecting those servers. In this case, basically 6740s, 1G or 10Gs, and then we have a 40G here as well. So it's just building blocks. 48 ports, 10G for example, then 40G uplinks, and it's just very basic stuff. Then we have a 36 quad SFP pluses, and this is a bit 144, so it's already a 2 rack unit high switch, and then more like a chassis-based core devices as well. I don't know how you see that. Unfortunately, we don't see that much anymore that customers are building their network with a chassis-based solution. So it's more and more these kind of pizza boxes. So how you see that? Are you still implementing new chassis, or is it like just 1 rack unit high pizza boxes? Because at least this is much more cost-effective way to do network, but from the other hand, this is much more sophisticated way to do it. So if we are looking about the VCS fabric, virtual cluster switching, it's completely non-blocking, loop avoidance, and workload mobility. So it really can do the load sharing automatically between or inside of the fabric. Plug and play, so it really means that you can add switches automatically and start to connecting cables. You don't have to do anything. And the Trill protocol is doing basically everything for you. Single virtual IP management, storage ready, auto quality of service, and so on. Multi-tenant, you can really isolate services inside of the fabric, fully VMware integration, and it's I would say that the most used our fabric at the moment. And but of course there's limitations about the VCS fabric. So basically, this VCS fabric can scale up to 48 switches. No more than that. And basically the reason is that all of the switches inside of the fabric are basically sharing the same configuration. So it can't be scaling more than 48 devices. You will see a bit later as well. So if we are thinking about the scale out thing, so scale up was just adding more and more layers, and this is basically the spine and leaf architecture. And why it's basically the easiness how to configure, how to add switches is, from my perspective, the key thing why somebody should think about this kind of fabric. So just embedded automation means the drill and just adding those. Then we have this workflow composer. Then if somebody is keen to do some scripting with a Python or something, then there is a API, so you really can do the integration between different systems. And if we are thinking about how easy it is, so with the VCS fabric, basically there's no any commands. And if you think about that, you really would start to do something like this, and you have a repeat same commands to other end of switch, so it's not that convenient. So everything is basically automated. And if we are just adding more ports, automatically it will be port channels, or all the VLANs, all the quality of service, and blah blah blah. So what is the real values? Okay, all links fully active, multipath, layer 1, 2, 3, self-healing. If something dies, it's just automatically the drill is basically using or doing that. And just operational costs, because it's easy, it's flexible, you don't have to use that much time. And if you're thinking about the upgrading the fabric, you will do it with a single device by the device, so still you can get it's a very high available thing. Multi-tenancy, zero-touch, VM discovery and mobility. So we really see where those virtual servers are and so on, and the REST API. About the VMware integration, so I think here the distributed hardware VTEP with the fabric is one of the key things. How many you guys know what is the VTEP or VTEP and so on, and what it means and where you need it and why you need it?
No idea.
So basically, is everybody aware about the VXLAN concept? VXLAN is basically overlay protocol where you are interconnecting two different data centers which are in a separate networks. So you really can still have layer 2 between or overlay the layer 3 network. And when you are getting out from the VXLAN, you have to have a hardware that you can transfer the VXLAN to regular VLAN. So it's like bridging from the VXLAN to regular LAN, VLAN, layer 2 LAN. And it's just about the how you interconnect those different data centers, and it's VMware related stuff completely. So if we are looking about I think this is quite nice as a picture. So we have 2, 3, 4, let's say core devices or spine devices. Then we have that many leaf devices, what we need. It's always dual homing, so you have a server and it's going to 2 different switches, so it's very, very, very reliable. Normally we need only, at least inside of the VCS, it's layer 2 always. We can do routing here as well on the access level if we want. So then we can do just that we will minimize that. If we are doing routing here, it doesn't have to go, let's say, to the spine level. So we can do the decision here that where the traffic is heading. Okay, dual stack. How many of you are really using IP version 6? Because it has been, I still remember early 2000, in Finland, Nortel guys, they had this Volkswagen Beetle, and the register plate was IP6 or IPv6, and if there was, is it a bubble or is it really happening? And it's been almost 20 years that we are saying that the IP addresses are running out and we are heading to IP version 6. And okay, in a mobile world, I think it is IP version 6 already, but in the regular way, that how on earth you know that what is the IP address? So it's still the IP version 6 or 4 addresses we can remember, but even realize that what is the IP version 6 local address or router address, and so it's, at least to me, it's nightmare. So I truly hope that I can retire before the IP version 6 is really there. But okay, it's dual stack, so both goes. And here we can see that if we have a need for the better scalability, we can put one fabric here, one fabric here, we could be here as well, and then we have a basically aggregation fabric between. And we really still can automate that. If we are doing some services here, it will be propagated automatically to the core and to the other fabric as well. So that is doable. So let's say we have a backup or remote redundancy site somewhere, so it's really doable, or even with a single location, why not? And here you can see the layer 3 or overlay data center interconnect with VXLANs. Any questions about VCS fabric? Drill-based, topology-free, easy to configure, limitations up to 48 switches. Should we make small 5 minutes break here before we are going to the IP fabric, because it's, yeah, so if you want to have a water or something, which at least I'm sweating.
Aga teeme siis väikse kiirepausi. Käime kohvikastid ja.
No. Sa telefoni seda vaatama. No. Seal oli see äge tolmuime, panin kookas ligi. See oli see no. Ah, see oli no. Jah.
Parandus ühe lehe ära ja.
Kes ei mäleta?
Tegi
suction.
Ei, ise aga ise siis mitte nagu 500 lehekülge. Minul ei õnnestunud. Aga kirjuta selle, ei, kirjutasin jah. Ei, no. So, try to get
Yo. I will not go to those 2x2 but that's for sure. The lessons are nice and relaxed. That might be. He wants to have the gets drowned, yes.
See on mustri värvinud. Tõrva. Ma olin tõrvast. Tõrvast olete.
I don't know, we have to do some planning things.
Võiks olla sellised, mis on siis kõike teha upgrade.
What we will say that
Absolut tuleb
planning.
You will be much more happy if you get this boat. Large Good.
Välisti ise maha, mul pole vaja otsa kinni.
Yeah, we can organize it. Aeropaadid, ei aeropaadid, nendel on siin raske, siin ma siin.
about the VCS fabric, and now we are heading to IP fabric. And basically, what is the biggest difference between VCS and IP fabric is about the scalability. And if we are here heading products first, we will here see already the first purple boxes, and I don't think that we will never change these devices color, but anyway, so it's again 48 ports, 6 uplinks, 40. Here we can see the 25G, 40G, 50G, 100G uplinks as well, and so on. And then again, some real chassis-based solutions. So here we had the very hierarchical legacy way to, old-fashioned way to build networks. Then we were discussing about this scale out on the east-west way with the VCS fabric. And basically then, now we are talking about the scale out with the IP fabric. So this is basically pretty much driven by cloud or when you really need a huge scalable data centers. So when the 48 switches or it's not enough, when you really want to have a, let's say, real big ones. And I think this is pretty good slide. So general design requirements. So it always has to be non-blocking. It always minimal spanning switch. So minimum number of hops. Of course, it has to be very stable, and also it has to be easy to configure, maintain, and so on. And if you need most likely more capacity, you are just connecting or adding more links between the switches or the place where you can see that where is the bottleneck, that where you really see or need more capacity. And if you remove something, there is no any kind of impact to the other traffic at all. So from that perspective, it's just how we are getting from E to where and so on. So it's just very basic stuff. But if you don't put any attention to that in the beginning, then the result might be a bit wrong. Then if we are thinking about the BGP, everybody knows that internet is built based on the BGP routing, so it has to be scalable. It's top of IP, all the Microsoft, Facebook, Google, Amazon, all of those data centers are running top of BGP. So we know that it's scalable, we know that it's also robust and it works in all of the situations. So from that perspective, it's very nice. Also, if we are really comparing honestly about here different vendors, when the BGP is standard, you can use our devices, you can use Juniper or Cisco or whatever. It has to work together, and then you are just doing the, let's say, layer 2 connectivity using those VXLANs, what I already mentioned. So first, you have to have the, let's say, underlay network, and in these situations, it really means that you have to have the IP connectivity between the devices. Then basically BGP, EVPN is the control plane, how to make the topology and so on, and VXLAN is basically the data plane, how to get those servers connected between each other. Again, spine and leaf, no any real old-fashioned way to build networks. And here in the spine, we have private ASN with the BGP. Then all the leaves, either dual-homed or single-homed. And these have between this, it's BGP, let's say, signaling. And here, of course, we have a public ASN, so we can have access to external world. So this is just with the BGP and the external one. Equal cost multipath, bidirectional forwarding. So, okay, minimal features. We still have to keep it as simple as possible. It is very scalable, as I already mentioned. And with this bidirectional forwarding, we are getting better fault tolerant. And then multi-vendor interoperability. So it really has to work with the other vendors as well. Here you can see a bit more detail about how it goes, but no any huge differences. So how it really works basically is about, we have the layer 3 connectivity, then just dual homing from servers to leaf. Then LLDP is basically those devices are discovering each other, how those connections are made. And then just it's about how easily we can automate the BGP protocol, that it really, we will get the real network up and running, let's say easy way. Here is again about this VTEP, so hopefully everybody understood what I was saying. So it's just about VXLAN to regular VLAN or vice versa, because this is the virtual server environment. It's not real world from that perspective, and from getting from the virtualized environment to the real world, you have to have a VTEP. This can be software as well. But if we have a lot of traffic, it has to be hardware that it's fast enough and so on. And of course, you can put at least 2 of those, so you can, or you will get redundancy. So it's just basically VXLAN channel endpoint or gateway, or how you can name it. So if we are looking then about the IP fabric, so I would still say that the biggest difference is just about the scalability. This is more complex comparing to VDA or VCS fabric, because the VCS fabric was completely automated. Here we have to do really things up front and get it this part done. But both SLX and VDX switches are supporting this IP fabric. Honestly, I don't know any IP fabric what we would run in Finland or at least in my territory. No. So this is relatively new to us. It has been, let's say, 2 years, and because at least our team, everybody is old dog and we don't learn new tricks, so it's just that it's better to use the legacy VCS fabric, because we know by heart, and also the limitation of 48 switches. It's from our perspective, it's big enough. We don't have that many huge data centers where we really would need an IP fabric. We have had a couple of discussions about that somebody are really pushing to this way, and then basically if 25G for the server is coming more and more common, then it might be that we will really see, let's say, more this kind of IP fabrics within year or two. But both route leaking, VRFs, VXLAN scale, VRF scale, there's no any real difference between VCS fabric and IP fabric. Then if we are looking about the automation and visibility, in the first slides there was also about the packet broker, so that gives you a chance or view that what kind of traffic there is really is in the data center. But I think this is pretty much good automation journey. So just entry into the automation is basically something what is embedded or inbuilt into the fabric, either VCS fabric or campus fabric or even to the IP fabric. So it's just about you only have to provision services on the access level and it will be propagated into the network automatically. Then if we are thinking about more advanced stuff and really either using RESTful APIs or our management center or Python and scripting and so on. So if this happens, then we are doing this or that. Or then the workflow composer is about the cross-domain automation. And I think the cross-domain is just that if you are adding new server or new user into the network, it automatically does some tasks what we have defined it up front. Or if some log message, as Timo said, that if something is happening, then run this kind of scripts or test this and this and this, and if the result is this, then do something. So it's really about how, at least to me, it's still a bit blur, or it's hard to imagine that what kind of tasks I would like to get into the network. But I think if we are just defining something bad is happening or good is happening, then we have a possibility to react immediately, or then just raise a flag that something is happening and have a look more detailed. Okay, it's just same story basically. So cable up, leaf and spine, configure management IP address on all the switches. So then this is about how to make a IP fabric. So then just add those spines or leaves. So it's not that complicated, even it's more complicated comparing to the regular fabric. And then just about those third-party tools. We will see first. There's in a switch, basically, there's a capability to run virtual hosts or virtual machines. And to me, it sounds that why on earth I want to run servers in my switch? It doesn't make any sense. But there's a couple of, let's say, use cases where it might be useful. So, example, you can run Wireshark inside of the switch. So you don't have to go remotely on site and make a backup file. If you can just take a SSH connection to your virtual machine and look at what you want to capture and then just copy it and so on. So that's one thing, but it's interesting possibility in the future that what we really can put inside of the switch and run it there. So basically it's just about guest VMs or applications. I don't remember, was it 3 or 4 servers what we can run at the moment, but to me it sounds a bit weird. Here's an example about the workflow composer. So it's just about what we want to do. If we are detecting something, then just acting. And this is in a NetSite or XMC. It looks a bit different, but it's just GUI-based automation. And here is just that we have to have some kind of input via GUI, then we have some kind of variables, then we are just doing something and blah blah. It can be that in this case it's just that we are creating port channels and switch ports automatically. So this is just for the IP fabric, not for the VCS fabrics from my perspective. And just everything goes nicely. So the TCP dump was my example, or Wireshark. So we really can have a look what we want to push to the guest VM and so on. We can have I think the Splunk is the most common one, so we can push some data to there as well. So we really can do some kind of analyze easily. And then about if user is basically my application is slow. From my perspective, I still would use extreme analytics instead of this, but we can try to determine what is the root cause. And just via the workflow composer, it can automatically start to pushing some data, to example to Splunk, and then just analyze what is the real cause. And then just when we know it a bit more detail, the workflow composer can just do changes based on the feedback what it got, and then customer is happy or user is happy. But I think from slide to reality, it needs a bit testing and seeing and so on, that it's not that simple as it looks. So this is about the packet capture. So it's, I think, best example about what we can put to the guest VMs. Timo,
yeah.
Do you have any other examples about the guest VMs, not Jazz or Pacman or anything, but
we are planning to deploy or implement the Extreme Analytics, for example, as a guest VM, for example. So we could basically get the analytics, layer 7 application analytics directly from the switch to that VM, basically, and through XMC we could see what are the performance metrics and so that's one example. Mostly I would say it's around the debugging and remote packet capture.
Perhaps later on, when we really start to see that what is happening in a network, we can start to blocking or doing something, or it could be not firewalling, but just preventing traffic, just using these VMs or something. So, but this is nice because you just don't have to go on site and do something, so you can do it remotely. Then about the routing, so before basically we both Brocade Extreme has been always switching house. We have been layer 3 capabilities, of course, and we have done BGP and ISIS and so on, but we really has not been routing house at all. We couldn't say that we do layer 3 MPLS or anything like that. We did layer 2 MPLS, yes, but with a quite limited feature set. But this is the first time when we can say that it's really about routing as well. And it's about the SLXs or MLXs. So here you can see something about the scalabilities, how many millions of routes and so on. So it's just basically getting out from the data center, or why not building layer 3 MPLS networks as well. No any changes. Then basically the last part is coming from the Summit side. So this is the legacy extreme stuff, and there's a couple of new features what I would like to introduce to you here. So basically VPEX is something what we introduce on this spring. And what it really means is about, let's take this one. So we really can use port extenders. So from that perspective, that this is, let's say, control bridge, and it can take cascading these port extenders up to 48 per control bridge. So this looks, or all of these looks like a one slot in a chassis. So again, one single management IP address, and just adding more ports what you need, and so on. If you want to have a redundancy, or of course you want to have a redundancy, because in this case, if your root bridge dies, whole network will collapse. So in this case, we have a redundancy. Both of these still has been managed with different IP addresses and so on. But this might be some new way to build regular networks or build data centers or whatever. So from that, if we are comparing these to VCS fabric, okay, here we have a quite strict topology how it can looks. But in a VCS fabric, it's completely topology free. But again, if you are thinking about the regular network, it's pretty much, you have the core and then you have an access level, and your cabling is basically setting up how the network looks like, or how you can really build the network. Inside of the data center, most likely the cabling is more flexible because the distances are shorter and you can really make a full mesh or partial mesh or whatever. But it's a very scalable and I think just to us it's completely new way how to build either data centers or either regular campus or let's say office networks as well. Any questions about this or comments or?
Some comments from my side. I have these same slides basically, or some parts of these in my presentation, but basically while you have been discussing about this, so basically the idea behind this is that the port extenders are quite or relatively cheap, and they have all the functionality that we have in IXOS. So basically you could do your role-based access control, dynamic access control list based on those roles, authentication, and all of that stuff, which is enhancing security in the networks as well. So, yeah. So the idea basically is that you could create and ease the deployment, ease the configuration of the networks, and still have all the functionality that you would expect on the edge devices.
In your case, what do you think about something like this into the data center, or would you use IP fabric, or would you use regular VCS fabric? What would be the most, let's say, what would fit to your needs mostly? This or IP or VCS? Or none? You still want to build a regular way that you are using spanning tree and you have core aggregation and access?
Basically, it depends on the size of
Yes.
the network you need.
Yes.
And usually, the ordinary networks in Estonia are not so big.
Yes. We have the same problem in Finland, so it's just normally the IP fabric it's way too scalable, or we don't need it, because just building a data center with 48 switches, if you think about, let's say 48 or 50 ports and 50 switches is 2,500, so you can get, let's say, 2,000 connections, 10G connections. We don't have that kind of networks in Finland, and then if you use a chassis-based solution, then it's scaling up even much more. So it's just about what is easy, what is comfortable, and so on. So from that perspective, the VCS fabric is at least most referred to me. This I could think about even more. Okay, it's a data center thing, but it could be also in a just with the regular access switches, and as Timo mentioned, that those are feature-wise very rich, price-wise not so expensive. So and again, it's only with managed by from the two different IP addresses. But then again, because more or less I'm old dog and doesn't learn new tricks, so to me it's always nice that you can take a SSH, so you have a single device and single management IP address. Then it's very clear that I always know that which part I'm configuring. But in this case, you have to, okay, these are just blades or I/O modules inside of, let's say, chassis. And in the VCS fabric, there's also that there's a, let's say, switch number or bridge number is making the difference that what you are really configuring. So you have to be very careful that you know that you are now configuring the right product or right device. Or you are doing it with the automatic way and you don't have to do anything anymore. So you can just focus your time to planning and relaxing and so on. So it's easy life when you can get the automation up and running as it should. And this is more like a recap from the previous years, so focus to the quality of experience. So really measuring and seeing how the network works, what are the user, let's say, feelings about how everything goes. So we have a visibility about VMs, visibility about applications, devices, and so on. Is it poor, average, good, or excellent? So we have a really in-depth visibility. We can control the traffic when we have the visibility, and we can do something based on the inside information what we are getting. Hopefully everybody remembers this slide from the beginning of the presentation. Please raise your hand if you don't remember, or if you haven't seen it before, but anyway, it's the same, so let's just skip it. So this was the main idea. So we really can see the application response times, network response times. Is it in green, red, or yellow, and what is happening, and so on. Let's skip this one. Then it's just integration, for example, to VMware. So we really have we can automatically generate VLANs when somebody is applying a new virtual server. It will go to the correct VLAN, correct place, and the VLAN will always follow the server if we are moving it from one data center to another, or if we are doing something like that. We can get the host reports and what are the availabilities, how much traffic in, out, and so on. And here we can see example about just applying the same security rules to our own data center and to Amazon cloud. So definitely, if you want to move some data from or some servers from your own data center to public cloud, you really would like to get the same security rules in the both sides. And this we can do automatically. The Amazon is the first one. We are doing same with Google, and I think the Microsoft was a bit more trickier, so that's on the way as well. But it's just about the APIs and interconnecting public cloud and our own data center.
Question for you guys: How many of you are running, let's say, some sort of virtualization on-premise, and are you considering of transferring something, or have you already transferred something into the public clouds? Is it Azure, AWS, or something else? Or is it classified information, so you cannot say anything? I'm curious because it's at least in Finland we can see quite a lot, let's say mid-size and even smaller companies transforming their workloads and servers into Azure, for example. AWS is not, or Google is not that popular, at least in Finland, but I don't know about you guys, so just out of curiosity.
This is shadow IT.
Yeah.
It exists, but no one knows.
Yeah.
Well, in general, software as a service is getting around quite well in Estonia. Nothing big like Azure or something like that.
Yeah.
For Office instance, people are moving to the 365 and so on.
Yeah.
So they are beginning to trust the cloud, slowly but surely.
Yeah.
I trust all the clouds. They are mine.
Good. Yeah. As long as they are your clouds, yes. But I think now it's time to have a break and some sandwiches or something. If you don't have any questions.
I have a question about the embedded fabric management. Where does it run, or what's the host?
I think it's just because it's running in all of the switches, so it's like a spread.
Are we talking about IP fabrics or the VCS fabric?
VCS. If you set it up on one switch,
Yeah.
then does it replicate itself? So if the main or the first switch goes down, the whole fabric doesn't go down.
Yes.
Because all the switches are sharing the same configuration file. So when we are adding the first one and then the second one, these are just, let's say, mirroring or duplicating it. And then when we are adding the third one, then they are starting to share the same the configuration. And if the first one dies, then still the fabric is up and running, and it's basically it's spread between the switches.
Yeah. Okay, but the logic or the smartness of the fabric is replicated as well. So if you connect two switches with one more link, then it automatically recreates the link.
Yes, yeah. So it automatically detects that if you have just one link and if you're adding two links, it automatically it's first 10G and then it's 20G and 30G and 40G and so on. So you don't have to do any manual configuration at all.
It's basically doing just normal signaling, and it knows that okay, my neighbor is a VDX switch, so are we part of this fabric? And then it's basically there is just a couple of steps basically what it's negotiating between the different nodes, and then automatically it can configure all the VLANs. And the fantastic thing about those additional links is basically it's doing load balancing in layer 1, layer 2 and layer 3. So it's basically much more efficient than normal link aggregation, because it's basically using the same kind of functionality that we are running on the fiber channel stuff. So yeah, so you can basically utilize all the links 100%.
Even with if you have only single device and single device here, and it really do the load sharing between. So it's not just a regular link aggregation that one MAC and one MAC, it's just utilizing the single link. Even you would have, let's say, 8 links between.
Yeah.
But it really now do the load balancing between all of those 8. Yeah. If you have 8 links, just.
Does it do unequal cost load balancing as well?
You mean?
So if I have like let's say 20G link, logical link, and I have another 10G link through the core. Does it use the 10G link when the 20G becomes saturated, for example?
Basically, it's
Marek put in some traps, traps or something. So
basically, it's packet-based load balancing. So if so we have 20 gig links. So packet A will go here, packet B will go on the second link, and if depending, of course, what's the path cost? Is it better actually to utilize these links or run it in the third one, which is, let's say, a different route?
But basically, the question is, does it have the throughput or the utilization as a cost metric?
You can actually configure that if needed. So you can basically create different. So yeah, you can manually adjust the link costs if you want to, let's say, steer the bandwidth towards some link
or the load balancing algorithm. But I think by the default it's packet-based.
Yes.
Because it's the most efficient way to do it.
Yeah.
Okay, time for a break.
Saad, siis sa saad nagu full täiesti see põhimõtteliselt kui Järvevann on umbes
ei ma seda kätte võin
sul on umbes sul on selline ühendus
on fiber cover. Fiber cover.
faili tasemel backup ei tee.
No selles suhtes, et kustutad faili ära ja...
sa mõtled faili tasemel taastamist?
Jah, absoluutselt.
I will most probably not torment you as long as my colleague was presenting here, so I will try to be a little bit faster and we can have some, let's say, spare time and then get something to eat and go to the sailing event. But anyway, so the topic here is basically Smart OmniEdge. And what basically that is our marketing terms. So basically this is something to do with edge computing, edge networks, edge devices, wireless, wired connectivity, and so on. So basically nowadays we have, let's say, our automated campus solution, which is one of the solutions, Smart OmniEdge, Agile Data Center, and automated factory solutions. So basically these are, let's say, new marketing names for the solutions, basically. So it's not that fancy, but anyway, so the agenda, so basically a little bit discussion about edge networks, introduction to the Smart OmniEdge, something about IoT, so we have a new product for IoT security and things like that, and then let's say, wrap up and continue with the day. So about edge networks in general, what's your opinion about how, or is edge network complexity increasing or decreasing? Because at some point, basically what most of the people were trying to do is get, let's say, or do all the security stuff and as less as possible at the edge or at the, let's say, access level of the network. And nowadays, I would say that we are starting to move back. So basically, more and more intelligence should be at the, let's say, access edge, directly on the access point or access switches. So in that sense, basically, it's the complexity is, in my opinion, a little bit increasing. I don't know if it's really much because of ways to automate things and so on. So is it really increasing or not? But anyway, so I would say the demands of edge networks are really increasing. So you will need to have really great Wi-Fi. So nobody wants to use wireless if it's not working, basically. So poor throughputs, packet losses, slow or huge latencies in the network doesn't make much sense. So you cannot run voice over IP on those kinds of networks and some other latency sensitive applications. So wireless is one of the key things. Increased number of attacks and of course some hacking activity and stuff like that is happening. So basically, if you think about the breaches in current networks, basically it's the access devices or end devices which are actually connected to the network. So basically somebody could plug in a USB stick or some other compromised stuff gets downloaded to those and you connect to your internal network and it starts spreading there. So basically you have to have some kind of means to basically detect those. So of course antivirus, anti-malware stuff and so on. But basically what can they do for the connectivity itself? Sometimes they can do something, but I would say most probably they cannot block, or at least if they can block, the user cannot get any kind of notification what is actually happening. So they are immediately starting to call help desk and saying that internet is broken, I cannot access this and that. So basically, For those kind of scenarios, the network access control, authentication of the devices, visibility of the devices, doing some sort of assessment on those devices, so we can check that all the latest patches are there. We are not running any software that is basically prohibited by the security policy of the company and so on. So we have to have knowledge about what is actually connected and how they are connected, where they are connected, what they are actually doing. So authentication, application analytics, assessment, and those kind of things are starting to be really critical things that you need to have in order to mitigate the possible security breaches and so on. IoT devices. Do you guys have any plans in your networks to deploy some kind of IoT, let's say devices, sensors, anything like that? So how do you manage it and how do you, let's say, do security on those? Because they could be something like, I don't know, just a temperature sensor or whatever. So there is no possibility to do firewalling on those or any kind of configuration on the devices itself. So if there is some means of hacking that device, how you can actually protect it. So basically the Defender is the option from Extreme to mitigate those kinds of problems. So we will discuss about that a little bit later. Basic maintenance of the networks. So some of you might have products from one vendor in switching and from wireless side from some other vendor, and they have different management solutions, different ways of configuring and so on. So basically that could give or do some additional complexity in managing the networks. And of course the support services for the vendor side of things, you need to have different, possibly different ways of contacting the vendor itself and doing tickets and stuff like that. And then last but not least, so basically the cloud services, as mentioned, so Extreme Cloud, for example, for wireless and switch management is one option, and of course some sort of hybrid deployment. So some line of businesses, of course, you cannot use public cloud, let's say, infrastructure management softwares in any way, because it's you just cannot use them. So you have to have on-premise solutions, or for example, I have an example in the slides from retail. So those kinds of places could be deployed as a hybrid. So you could utilize public cloud to manage the whole infrastructure, but on the larger retail shops, for example, you might need a on-premise controller to be able to cope with the number of access points and seamless roaming and other features that could be interested in, or the customers would be interested to have, and then basically smaller sites with just one or two access points could be managed directly from the public cloud. So we can do hybrid models as well. So you could have on-premise controllers, and they could be managed from the single cloud-based UI, for example. Makes any sense, or do you agree about the edge? Is it important? In my opinion, it is, because it's where the people are actually connected to the network, so it should work. So basically, what are the key blocks of Smart OmniEdge is intelligence. So artificial intelligence, machine learning, extensive APIs. So my colleague here talked a little bit about APIs, and the way that we are moving forward is that most of the products will have some kind of an API, programmable API, so you can actually integrate it better and use, let's say, additional tools and means to automate things and monitor things and do some kind of remediation if something happens automatically. So nobody has to go directly onto those access points or on the controllers and configure something. So we can create automation using artificial intelligence and machine learning, at least on the first phase at the wireless side of things. It has to be business adaptive. So many of businesses are transforming, they are changing the way that they are doing business because of digitalization and stuff like that. So basically, the investment protection, in my opinion, is one of the key things in Smart OmniEdge. So basically, the same hardware, either it's switching or wireless, basically, can be utilized in our on-prem controllers and on the public cloud. So if we compare that to our competitors, for example, many of them have, so you have to rip and replace, so it's only either a cloud or on-premise, so you cannot mix and match. And many of you know that we have two different wireless, let's say, products in our portfolio. So we have legacy Extreme Wireless, and nowadays we have Extreme Wireless Wing, which came from Zebra and Motorola side of things. So in our Smart OmniEdge and Extreme Cloud appliance and on the public cloud, we can utilize both of those in the same infrastructure. So it really doesn't matter. So you can mix and match from the different product lines. And later on, we are actually announcing the new AX standard access points. And they will be something that we are calling super spec APs. So basically they could, there is a single SKU, so you can actually bootstrap those access points into both of the solutions. So it really doesn't matter which kind of controller you have on-premise or in the cloud or whatever. So basically everything works. So investment protection in that sense. So we are supporting those, all of the products and investing in both of the product lines as well. So functionality and support is still ongoing on those.
One question about the AX access points. What it really brings compared to AC Wave 2? What are the real advantages? Or
basically, capacity in a way. So you can, or the new access points will handle much more clients per single access point, and there should be much more capacity in the air because of new technologies and slicing of the let's say RF in a way. Basically, I don't want to go too deep about the AX and all of that. I have a separate presentation about that, so if somebody's interested about AX and what is bringing, so we can have a one-to-one or some kind of chat about that.
But how many is many or more? How many clients?
We are talking about thousands of clients more, or thousands, hundreds.
Okay.
It's a difference, hundreds or thousands.
Yeah.
And then question about the wireless security and VPA3. It will come with the AX access points or how it goes?
For AX, definitely. And we are in the works of deploying it to our AC Wave 2 product lines as well. So both Extreme Wireless and Extreme Wireless Wing as well. But I don't have any details about when we are going to release that, but as far as I know, currently VPA3 should be supported on the current active lineup of access points.
Okay, but now for the first gen AC lineup?
I don't know, to be honest. because what I've read is in our internal discussions, they were only talking about AC Wave 2. I might be wrong.
Yeah, but
Technically, it shouldn't be an issue for the Wave 1, the first result as well.
No. Basically, it's just the software that needs to be implemented. So it doesn't require any additional stuff from the chipset side of things. Of course, there is always with VPA3 there might be some problems because, of course, the clients need to be VPA3 capable as well, and VPA3 is, of course, backwards compatible with VPA2. And I don't know about the details. I don't know. Have you, Martin, read about this at all, or? Yeah, because I don't know how it works. So can we basically mix and match VPA2 and VPA3 in same SSID, so they are both working at the same time, or is it just basically working when all of the devices are VPA3 capable and there is no VPA2 devices anymore on that SSID, for example? That's a little bit blurry to me, at least. I don't know if somebody here knows. Let me know as well.
Well, isn't it key change algorithm? So if you authenticate yourself, then it doesn't matter.
Yeah. Yeah, but of course, the keys are changing. Yeah, I don't know. Yeah. So yeah, but about the Smart OmniEdge. So basically, security is the third, and I would say one of the most important things. So user security, device security, and application security is built in the solution. So how this works is basically the access control, authentication. So we can see the devices, we can create those access control lists from layer 2 to layer 7. So quite huge potential to actually tighten the security on the devices, so whether they can actually access how and where and when and so on. And of course, we could deny or do quality of service for some applications and things like that. So what it is, basically, it's a product or solution that will simplify the complexity of the edge and ensure that you have possibilities to be successful on the business, so you don't have to be worried about how our access, let's say, solution is working, and because it's really intelligent thing, and with the artificial intelligence and machine learning, we can do quite nice things and optimize the wireless and so on. So it provides a secure, unified wired and wireless infrastructure, and it's really capable of optimization or doing optimization for the wireless, and it's managed through a single management console. So basically, either with your on-premise Extreme Cloud appliance or from the public cloud or some sort of hybrid deployment. So what's new is basically the Extreme Cloud appliance, Extreme AI, so the artificial intelligence, extended edge switching, so basically those are those port extenders that were already mentioned, and then we have this Defender for IoT, so a solution to create secure or additional layer of security for wired IoT devices. Basically, those could be, I would say, the easiest example for IoT security basically could be something like medical devices in a hospital environment and something like that. So I don't know if you remember this ransomware attack, which was actually causing a lot of trouble in many lines of business, and hospitals were one of the biggest things who suffered in those. So old Windows XP embedded devices were infected, and so on. So we could basically get rid of those and check the anomalies on the traffic and so on. So basically we could remediate and get rid of those kinds of problems in those kinds of devices. So where we are heading as an extreme and with the extreme cloud and extreme cloud appliances. So basically software as a service. Everybody is talking about software as a service nowadays. So basically management software can be purchased using software subscriptions and Cisco Meraki is software as a service basically. So you just buy annual subscriptions and you have the right to use those things. So we are heading into the somewhat similar route nowadays. So the difference is basically that you can utilize your own cloud. You don't have to be running our, let's say, public cloud in your environment. So that's where the extreme cloud appliance comes in. So basically it's a very similar product as we have in our public cloud, but you can deploy it on-prem and utilize that instead. There are some little differences, like there is a built-in network access control engine, and we do support containers on the extreme cloud appliance. So basically, Lonka mentioned earlier that in our SLX portfolio, for example, we do support guest VMs, for example, to deploy additional functionality. So in the extreme cloud appliance, we are supporting containers. So for example, the Defender for IoT is a separate piece of software that can be deployed into the cloud appliance, and that will enhance the functionality of the device. So basically, that's the first, let's say, software product that we are announcing into the extreme cloud appliance. So basically, later on, we are enhancing and getting new products onto the market much more faster, because the way that we can actually utilize containers or guest VMs, for example, is much faster than deploying certain functionalities into the, let's say, switch firmware or into wireless solutions. So basically, adding additional applications on top of the solution is much faster. So deployment, time to market is going to be faster and faster. So that will benefit, of course, you guys. So you will get faster deployment for the new technologies and things like that. So yeah, as mentioned, the cloud appliance and the cloud can be a hybrid deployment solution. So single, let's say, UI and extreme wireless wing, extreme switching. So some models from our switching portfolio can be managed through the cloud or cloud appliance, and of course the regular extreme wireless access points. So how the let's say extreme wireless and extreme wireless wing deployment differ from each other? Basically, we are talking about campus solutions and distributed sites. So basically, the distributed architecture is the wing, and the campus wireless is our regular extreme wireless portfolio. So how they are actually differentiated is the campus wireless is basically more or less targeted to be deployed in a little bit smaller environments. And the wing, because we have this functionality called RF Domain Manager, we can scale it a little bit bigger environments so that we don't need to have a on-premise controller there. So a little bit bigger environments in that sense. Extreme AI. So this basically is a cloud-based tool. So what we are doing is basically we are feeding the Extreme AI engine with, I don't remember how many parameters it was basically, but a really huge number of different pieces of information about the clients and different parameters of the RF. And basically what this piece of software does is keeping eye on those key performance indicators of your wireless network and clients. And it's basically optimizing constantly the wireless network. So I would say that this is more like radio resource management 4.0 or something like that. So first Symbol back in the day invented the radio resource management, so automatic channel configuration and power output changing, and then further on it has been developed and it has gone better. But now with machine learning, it's totally a new era of automation on the wireless. So basically, these are some screenshots from the system, so we can detect different issues. We can detect some radio causes, what kind of mitigations we are doing, so cell resizing, channel changes, steering the clients from AP to AP, and average improvements and unusable connection gains. So you will be able to see that what basically has the software done for you. So you don't have to be manually changing and checking and monitoring about DFS events and stuff like that. So everything is automated, everything is much more intelligent than it has been ever. So self-optimization, autonomous correction of network errors. So that's basically the idea behind the Extreme AI. One part, of course, this is new and we already gone through this a little bit. So the port extenders. So I don't really want to go in too much detail on these because I think you already got the picture about this. So this is basically, part of the edge as well. And here is some of those examples. So primary or secondary education deployments. By the way, how many of you have heard about extreme validated solutions or extreme validated designs? You could go into our webpage and, for example, for data centers, we have the EVDs, so extreme validated design guides, which are basically 3-part documents. So there is a solution brief, which is a small one-pager telling what the solution actually is. Then we have a little bit deeper document, which is a little bit longer, going into a little bit more detail about what kind of products and what is the outcome for. Basically, that's targeted for system engineers and administrators. And then we have this implementation guide, which is going through step by step every configuration that you would need to have, what kind of firmware versions do you need to run, and so on. So basically, we have similar EVDs on the schools, for example, running Smart OmniEdge solution there. And for the campus networks, we are on the works of announcing that as well. So we are going to create those kinds of documents for you guys, so you would understand and know how to deploy and what are the best practices in general. But anyway, back to here. So just an example. So basically we have our Extreme Cloud public cloud interface for managing this whole infrastructure. So we have a couple of remote schools and we have our main campus site. So we could utilize on-prem Extreme Cloud appliance on our main campus. We could run 590s, which are actually not yet available. I don't know, do we have any open books on 590s? No. So basically 670, 690, 590 on let's say during the fall, or at least I should say that it should be available.
Basically it's 24 ports, 10G and 4 or 6 times 100.
Yeah. So 10 gig access, 100 gig uplinks, cost effective. And we could run those port extenders on the wiring closets, the access points, security cameras, IP telephony, whatever IoT devices we want to do. And basically everything is managed through the public cloud. So this is a hybrid deployment scenario in a way. So wherever you are, you can actually log into the Extreme Cloud, see how all the sites are doing and do you have any issues on there and so on. Then we can add an additional piece of software into the mix, so Extreme AI. So that, as mentioned already, is wireless, let's say, some additional piece of software for the wireless. So it will enhance the quality of experience and how your wireless is actually working. So we can add that into the mix as well. So in a way, so you don't have to deploy all of this in the same time. Of course, if you need, let's say, Extreme Management Center, and you want to monitor and configure, let's say, third-party devices as well, we could deploy it on, for example, to the main campus. And you could be monitoring your firewalls, you could be orchestrating your, let's say, main campus data center. So if you have like VMware there, you could just create those or check how the VMs are running and do additional analytics, for example, if you want. So all of these, so basically the Extreme Management is complementary to the Extreme Cloud management. So it's not competing against, so you will get, of course, additional benefits and additional value from the Extreme Management itself. Questions about this? Do you understand the concept behind, or do you agree or disagree about the hybrid deployment? What could be the use cases, or does it make any sense to have this kind of environments? Because in my opinion, as mentioned, so people are beginning to trust the clouds. And of course, a colleague mentioned that we have not been that successful of selling the cloud-based wireless solution or Extreme Cloud in general. Of course, we have a couple of customers, but let's say not anything huge. But yeah, in my opinion, these kinds of deployments will be something that we should be able to see in, let's say, at least in the next 2 years, because how people are working and where they are actually working is changing as well, in my opinion. So basically, systems administrators could be going in many of the different places. So at least in such environments where you have many different locations where you need to be and do some maintenance work and stuff like that. So it really makes sense that you could access your management and check the status of the network from everywhere, all over the world. So it doesn't really matter where you actually are doing your job.
Well, perhaps you should start to offer a beer for a question.
Yeah. Bar is open. Yes. Okay, so second example, retail, so shops. Extreme low, okay, it's a little bit poor color, but anyway, so extreme location service in branch stores. So extreme location basically is a RTLS solution. So it can be utilized for asset tracking, it can be utilized to do retail analytics. So you can have your floor plans of the shops and you can see basically a heat map where most of the people who is actually coming into the store are spending their time and when they are coming in and how long they are staying and stuff like that. So it can be utilized in retail, it can be of course utilized in other verticals as well, so it's not just a retail specific product. But anyway, so once again, so Extreme Cloud, we can utilize the Extreme Location service on top of that. So both of them are cloud-based solutions and they are really easily deployed into the mix. And of course, if you want to further enhance the user experience in your stores and of course your headquarters and places like that, you would deploy the Extreme AI to automate your wireless configuration and troubleshooting tasks. Questions about the Smart OmniEdge in general? Did you understand what it was about? Does it make sense? Nobody's... Yeah? Somebody had a comment?
It does make sense.
Yeah. Yeah, I was thinking about, personally I was thinking about the Extreme Cloud appliance itself. So why we are actually, why we should deploy the cloud appliance, why we are not running, let's say, Extreme Wireless, regular wireless controller. You could do that. But basically, the cloud appliance and what's good about it is basically the management functionality of the switching. So basically, if you're running just normal wireless controller and normal switching, you would have different ways of managing those. So an integrated solution for managing the wired and the wireless. And of course, the built-in security functions like the network access control and the visibility of the devices. So basically you would know what kind of devices are in your network, where they are actually connecting, and so on. And of course with the APIs, you could automate plenty of stuff. So basically on the Extreme Cloud and on the Extreme Cloud appliance, all the functionality that you can actually do from the web UI can be configured through the REST API as well. So basically, the UI is built on top of the REST API. So basically, the UI itself is calling or doing those REST API calls and configuring the solution via that. Should we take 5-minute break before we continue to the IoT stuff, so you can regain your... additional paper, for example. So it might be that in some way, if that particular leasing company gets hacked, and there is some way of getting back to your printer, perhaps, through something, they might use some sort of VPN connection, or I don't know. Most likely, at least I hope so, that they would use something like email reporting once a week or once a month, saying that how many papers have you printed and what's the, let's say, toner levels and so on, so they don't have any constant, let's say, connectivity. But it could be. I don't know how they actually work. But I was thinking about these kinds of things and what happened?
That's it for today.
Unfortunately not. So yeah, but anyway, so think about different kind of possibilities that could be there in different kind of devices. Mirai botnet. So it took plenty of different kind of devices and used to do distributed denial of service attacks. So some kind of IP security cameras, printers, home internet gateways, routers, and boxes like that. Ransomware. So if you think about the digitalization nowadays, so basically you can buy a fridge from Samsung, which has a huge tablet, and it can save whatever is in your fridge. I've seen a picture, I don't remember where it actually was, but the particular display is basically an Android device, and it was, I don't remember what was the place, but it was hacked basically, and it was feeding some, let's say, adult content on that display. and it was a public place. So basically, even regular fridges are starting to be connected. Ovens, dishwashers, coffee machines, everything is connected basically, and they could use wireless. So basically, if something happens, they could be infected. They could be used as a ransomware. If you don't want to pay, we can do some nasty things. So we can listen you via Google Home Assistant or Amazon Alexa or Apple's HomePod devices, or these kinds of things are actually beginning to be more and more common in here as well. So there are plenty of places where you can actually be breached in nowadays organizations. And the price of the data breach is actually getting higher and higher, and not to mention about the company image. Of course, there is a lot of debate because was it a company called Equifax in United States, which is basically a company who is providing the information to banks. Would you be able to get loans or credit and things like that? So I don't even remember how many millions of people records was stolen because there was absolutely no security in place in that organization. That was even just simple data leak prevention, or some kind of signatures that if social security numbers or credit card numbers or whatever is going outside our organization, you would get alarmed. They didn't have even that. Let alone that they were using admin and password in some of their systems. So basically you could access those directly from places. So that could happen. But anyway, so they are not being held accountable, or they haven't paid any fees about because of the breach, as far as I know currently. So I don't know. Is the cost coming higher and higher? Maybe in EU because of the GDPR. If you violate those terms, then it can be a costly thing. Yeah, but anyway, so even, let's say, more alarming is the possibility that medical devices can be hacked and they can be remotely controlled. So basically, some infusion pumps could have been hacked and causing a lethal overdose for the patients, for example. And yeah, some of the firmwares were affected, so they could be hacked. So yeah, pacemakers.
Sorry, is a pacemaker connected to the web? How do you hack it?
I don't actually know how it works, but there has to be some way, because of course you have to be able to configure the pacemaker for the patient. I don't know, is it something that it should be pre-configured, because your conditions might change and they need to be able to, let's say, reconfigure that. So there is some ways. I don't know how or what protocols they're actually using, but obviously there is something. It doesn't have to be internet, basically. It could be some other wireless connectivity thing that you are able to exploit. If you think about the different protocols, so you have Zigbees and threads and Bluetooth low energies and different RF, let's say, protocols that could be utilized, and you could have some sort of gateway which is providing you the IP connectivity for those devices as well. So there is a number of ways. But anyway, so the number of connected devices is exploding, and there is little or no embedded security in most of the devices. So yeah, legacy, outdated OSs, hard-coded passwords. Some devices might even have some kind of backdoors. By the way, regarding backdoors, have you heard about this nice story about a mikä on silitysrauta? Iron, yeah. So you can iron your shirts, for example. There was this one device that you could buy from AliExpress. So basic iron, but it had an internal Wi-Fi and BLE chip. So each and every time you put it on power, it started scanning and tried to hack all the wireless networks that it could hear and send information to the cloud.
Basically the same was with coffee maker as well.
Yeah.
And it stays much more longer in that power network. So yeah, people just started to look at, oh, network traffic has gone up. So what's happening? Finally, it was coffee maker.
Okay.
This is especially made to have a better user experience. No configuration needed. Do it directly for you.
Mm-hmm. Yeah. Yeah. Anyway, so yeah, the number of different kind of devices, and it's often hard to actually do any kind of upgrades. They might be constantly in use, and they are running some mission critical, let's say, task, the devices itself. So you cannot upgrade it, or there is no upgrades available, and there is no way that you can actually even do much about the device itself. So Extreme Defender for IoT is one of the solutions that can be deployed for wired devices. Network access control and role-based access control and running the layer 2 to layer 7 access control lists for wireless devices is another way of deploying. And of course, the analytics part in conjunction of that is something that I would utilize for the wireless devices. But for wired devices, the Defender is the way to go. So it's optimized for, let's say, we are giving the example of hospital environments because there are a lot of things that are actually connected to the network and they are quite old. So yeah, so optimized for aging wired devices. So device may be mobile, it may be outside of IT's control. They are really old operating systems. And what we are doing is adding an additional layer of security in top of the regular connectivity. So can be deployed in any network, and you don't need to, let's say, reconfigure the whole infrastructure. Purpose built for healthcare at this point. So how does it work? It's basically, as mentioned, it's a separate application that can be deployed into Extreme Cloud Appliance. And the Extreme Cloud Appliance supports containers, so we can just basically really easily deploy the Defender application on top of the Cloud Appliance. And the hardware that you actually need is the Defender adapters or our 3912 access point, which has the additional Ethernet ports for the connectivity. Of course, those Defender adapters are much better in those places where you need to have mobility and the devices are getting moved from place to place. So what it does is basically secure onboarding, centralized inventory of all the devices that are actually connected, enforcement of security profiles and policies. We can do isolation and segmentation and additional healthcare user interface. So it's really easy to deploy that kind of things. Did I have the information here? Oh yeah, so the application itself. So there you can create the policies, what kind of traffic is basically allowed from what kind of device, how much bandwidth they are usually transmitting over the wire. So for as an example, so if we normally some kind of MRA machine sends a bursty traffic, like when the picture has been taken, it can be like 1 gig of traffic. They are transmitting the image to some kind of server, and then it's just quiet. So normally it shouldn't have like few kilobits per second or something like that, some heartbeat traffic or something. So we could detect those anomalies. So if we are getting much more traffic than we should be, or we are having something from the between the lines, basically. So we could block it, we could send alarms, events, and of course isolate the problem immediately. So single, let's say, management console for creating those policies and rules, what kind of traffic patterns, where they actually should be talking, and how often, and so on. And yeah, so the adapters, so basically this is size of a cigarette box, basically. So Ethernet in, Ethernet out, so just plug it in between your switch and between the connected device, and you're ready to go. We can, of course, create IPsec tunnels, some kind of hyper-segmented security zones, of course, depending on what kind of infrastructure do you have. So if you have our, let's say, automated campus or VSP line of switches, so you could do the SPBM, and with that we can basically create automatically some additional security zones and different LAN services automatically to the system. And of course, part of the solution is the cloud appliance itself, where this software is running. The Defender, or the let's say the boxes itself, are industry recognized. So we have had some nice awards. So this is not entirely a new product. So it has been there for some time, but we are just, let's say, getting and creating new use cases for the boxes. So this is just, let's say, a new product or a new way of using those boxes. So just one more slide to wrap up this. So what the Smart OmniEdge basically is a solution for edge networks. It's hardware and software combination. So we have different kind of pieces, different pieces of software like location services, machine learning, built-in security, network access control, really nice holistic management for your wireless wired, artificial intelligence, analytics in a way built in as well, so we could see, let's say, limited set of information about what's actually happening there. And of course, the extreme wireless switching and wireless wing portfolio is part of this as well. Any questions? Comments? I will buy you a beer if you give me one question or comment. Straight to the bar.
Okay, what will be in the next year's agenda?
What would you like to have as an agenda? What's basically, that's really good question, because we are always more or less repeating ourselves in some ways. So we are talking about analytics, we are talking about wireless and management and things like that. What would be, well, let's say, what are you planning for next year, for example? Do you have any projects coming along? What would be beneficial to you? What would make you more interested in Extreme and coming to these events next year as well?
I would split it up into two kind of approaches. One is a business approach, a high-level thing, the helicopter view on things.
Yeah.
What's happening, what can be utilized, and so on. Then is the technical side, because I'm running out of understanding of all the acronyms and shit.
Okay.
It's too technical at some point. And you can't have best of the both worlds.
I understand,
technical
yeah.
or business.
Yeah.
And the guys here seem to be a mix also of technical guys and the kind of managers. So
yeah.
You need to find the balance somehow. It's your job to find it.
Oh yeah. Yeah. Good comments. Good comments. I need to take my wallet now. Anything else? Yeah, that's about it from my side.
Thank you.
You're welcome.
Okay, we're going to look ahead from Shil.
Yeah, so you can go to the bar for beers. Timo will let.
If you want to have a beer, I'm happy to.
host has left the conference. The conference is about to end.